Welcome to ValueNotifier Simplified. I'm Scott Stahl. This is brought to you by Flutter Community, where you can find our GitHub, the Flutter Community Medium publication, Hump Day Q&A, which is live help every Wednesday via Zoom, and the Flutter Freelancers Virtual Office. Now, before I get started, I want to remind everybody of one very important thing. Our backup beat your Tom Brady. That's never going to get old. Anyway, if you want to support our work over at Flutter Community, you can head on over to our Patreon, right there, at patreon.com/fluttercommunity. A number of people put in an awful lot of hours, sometimes over 20 hours a week, bringing you all of this content. So it's nice to help compensate them for the time that they're losing that they could be working on client projects. Also, we do things like the Flutter Community giveaway of the London App Brewery course, and a number of other very interesting things tend to get paid for out of that budget, such as the trophy for the Hack 19 and all of the other expenses for the Zoom, plus any expenses for the upcoming Hack 20. Now, with all of that said, why don't we get started? What we're going to do here is we're going to take a look at a way to notify our widgets of changes that are only with the class members they care about and not that the entire class had a change. Now, when you're using Change Notifier and a consumer or even a selector, these get notified when anything in the class changes. This means you can have unnecessary rebuilds if a string changed but your color ends up rebuilding. Gotta fix that. All right. Let's get going here. We have our car class. Okay, it's called car model, but we're just going to refer to it as our car class. The way we set this up is we have a number of private members that really don't need to be reached from outside. So that's of course why they're private. We have a color for our cars. We have another color for a traffic light, telling us whether the car is going to be stopped or moving. We have the type of car and the color listed in a string, and also stopped or moving as a string. Now if we skip down here for a moment, we have our publicly facing methods. Now in Flutter, we refer to public and private, but for those who actually know about these things a little more, it's actually package private. If that doesn't make any sense to you, just know this. Package private means that nothing outside of your app can reach in and do anything. If it's truly public, then anything anywhere in the entire operating system can reach in and make changes in your app. So what we're going to do here is we're going to trigger one of these methods, and this right here is just a cute little way of incrementing what we're doing with each element in the list. So what we're going to do is we're going to set the new index value to be in this list, the index of the current value plus 1. And then by doing the modulus of the length, we're going to have a remainder. If the remainder is 0, then that's the element number we're at. If the remainder is 1 less than the length, that's where the element is going to be as well. So this will allow us to just increment and loop through the list. Then what we'll do is we will set the value of the color, of course, to that index. Then we're also going to do the same with the name. So down here we do the same thing with the traffic, and that brings us to the value notifiers themselves. So let's have some fun. First of all, you want to notice that a value notifier of type color is not the same as a color. Absolutely not. We're calling it color because that's what we're going to be using, and that's the value inside the value notifier. But what this actually is a value notifier of type color, and right now we're setting it to the first index, which is a white beamer. Then we set ourselves up with a getter. Normally you don't see these in Flutter. They're not really necessary in Dart. However, here we're doing this for a little bit of extra assurance that nothing's going to be able to reach in from the outside and start changing things in ways that we didn't really expect. Now, the only thing that can change this is our methods. So that helps protect against bugs right there. And also it kind of helps ensure one-way flow of data a la Redux, because from the UI we come in and we have to trigger one of these methods, which now reaches up to the value notifier. The value notifier then is going to trigger a rebuild in anything that uses this particular color value and nothing else. So then those widgets are going to reach in and get that value from there and rebuild. Now, there's an interesting little problem when dealing with provider, and that is that you can only provide one instance of any given type. Now, this is what makes it impractical to use with primitives. You can't really do very much if you can only have one string. Let's face it. The limitation here is not Remy's fault. Okay, Remy Rousselet. I hope I got your name right, Remy. But he is the author of Provider. And the limitation here is coming from the framework. Now, Provider is using inherited widget under the hood. An inherited widget has something called inherit from widget of exact type. Notice I didn't say inherit from widget of exact instance. Okay, this has got to be a type. So if we had 3 cars and we set them up 1, 2, 3, and then we have all of our widgets, what's going to happen is when we try to use it, those widgets are going to look up the tree until they find the first car, because that's the exact type that it's looking for. And then it's going to stop looking, which means we're only ever going to be able to access the last car that we set up and never reach any of the others. So how do we get around this? How can we have a lot of cars and still use provider and value notifier? And the way we get around this is we create a fleet of cars. Now we have a whole bunch of cars. You can dynamically create more cars in this class if you want to. You can do anything you want. But the trick is you provide the fleet, not the individual cars. Now, the way this all ends up working is we have, of course, our main. We're running the app here, VNS example. It's a stateless widget. We're going to return a provider of fleet of cars. So then we create with the context and we return a fleet of cars. So material app and user interface. When you use provider, I tend to try to make this declaration as close as I can to where it's actually being used, with only one build method in between. That is because we need to have a new context created that has that fleet of cars in it. There are a couple of other ways to do it, but the common way really is just to have one build method in between the two of these. So what happens here is we create this fleet of cars, then we go down here to the user interface. And in the user interface, when we create this build, we get a new context, and that is now going to include this fleet of cars, and so we can actually make use of it. Neat little trick, something to annoy your friends. I didn't say entertain, I said annoy. A stateful widget is actually stateless. It doesn't change state. It's true. Look at it this way. Stateful widget. Constructor is user interface. Now, every widget needs a constant constructor and a key. This has only come down within the last 9 months or so. It helps prevent bugs. Don't worry about it. Just do it. Drink the Kool-Aid. Say, I believe. So then what we're going to do is we're going to create a state. And then nothing ever changes. the state of the stateful widget never changes. It's the state of the state object that changes. So a stateful widget is actually stateless. It's the state that changes. And the state, here's where it gets really fun. You know how we told you everything's a widget? We lied. We lied. It happens. You'll get used to it. A state is not a widget. It's a state. One of the ways you can tell is it doesn't have a constant constructor and it doesn't have a key. So, just a little tip for you there. A state is not a widget, even though everything's a widget, but you also have to remember that a stateful widget is actually stateless because it never changes. Anyway, did you get that? I didn't think so. Moving on. When we run our build method, we're going to create an instance of our fleet of cars. So the way you read this is the final fleet of cars, called provided fleet of cars, is coming from the provider of the fleet of cars within this context. Final is because the object never changes, but the value of it can still change. If the value never changed, then it would be called constant. But in this case, it does change. But we will declare the final fleet of cars called provided fleet of cars coming from the provider of the fleet of cars within this context. Did you get that? Back things up and write it down. Moving on. Scaffold, column, sized box, all of this normal happiness. So what we're going to do here is inside of our row, we're going to want to have 3 columns with a couple of dividers. So in order to keep them even, what we're going to do is we're going to query the device within this context. And if you don't know what context is, if that's a little confusing, think of it this way. The context is the situation of all things in the universe. Okay? If the bird is on this branch rather than that branch, the state of the universe is such that the context is the bird is there. Okay? If the car is blue, if it is moving, that is the context of the app. The context also includes how big is the padding or on the top of the screen to allow for the status bar. How many pixels wide is the screen? How many pixels high? Okay. Does the user have accessibility set to increase the size of the font? These are all things that are inside the context. And this way, we can query the device within this context to check the size of the screen. In particular, we want the width. Then we're going to multiply that times 0.3, which is just a hair less than an actual third, because we're going to leave some room for a couple of vertical lines. And then we're going to space this whole mess evenly. So now we get into the column, and we can start with the first car. Now, the first car is going to be created with a value listenable builder. The value listenable builder is going to be listening for a type color. The actual value listenable, in other words, the value notifier that it's listening for, is in the provided fleet of cars instance, which we made up here somewhere. There we go. Up here. Back down. And then within that instance, it's going to be car number 1, because there is an instance of car within our fleet of cars. And then it's going to go to the color value notifier. Not the color itself, but to the value notifier. Now this is kind of important. When you are using the value of a value notifier directly, not like this, but directly, what you'll need to do is something similar to this. Now, first of all, let's get rid of const, because this is going to be a lookup. And whenever we have to look something up, it can never be constant. I cheated. Cut and paste. Do it the easy way. Why is it red? Now, you can't see the pop-up that you normally get because of the way OBS Studio is doing this. I'm showing you the actual IDE on the screen, so it's not showing the little pop-up. But the pop-up is saying that the argument type ValueNotifier of type color cannot be assigned to the parameter type color. So how do we get around this? Well, instead of using this ValueNotifier, the getter, we need to actually access its value. So this is really tricky. VALUE. Done. Now we're going to get a color out of the ValueNotifier of the car number 1 instance of the instance of our fleet of cars. Got that? Back up, write it down. Now why, oh why, is the linter complaining here? Well, the linter's complaining here for the exact reason that you've probably already read in the comment. The linter is complaining because we're supposed to put children values last. And there's a reason we're not doing this. It's because it's much easier to follow this way, at least for the first time. So we're now listening to this value notifier of this instance within that instance. So now we come down here to the builder. The builder checks the contents, and it checks the context too. Then we have a color, because a color is the type we're going to be using. Now these are positional parameters. So you just have to remember the first one is the context, the second one is the type. And we're going to call this the value passed in from the ValueNotifier on an update. How many of you are old enough to remember an acronym that came out to mean the artist formerly known as Prince? Kind of like that. Yeah. So anyway, the value passed in from the ValueNotifier on an update. That's what it actually is. Then we have the third positional parameter of type widget. It's always going to have to be a widget, although you can be more specific. And that is the child of the value listenable builder. Wait and think about that. The child of the value listenable builder is up here. It is an icon. The particular icon is directions car, and it is black. Now this could be a great big list view with lots of things in it, and nested list views, horizontal and vertical, and very expensive. It could be a big expensive mess. Okay, and the thing is, when this rebuilds, we don't necessarily want to rebuild that whole big expensive mess. So what we do here is in the third parameter, we say this is going to be the child of what's rebuilding, and we don't want to bother with rebuilding it. We're just going to reuse what we've got. Okay. So then what's going to happen here is we will return whatever it is we return. And that is a floating action button in this case. Now the background color is going to be, of course, the value passed in. So whenever this updates, we're going to change the background color of the floating action button. In order to call the method, in this case, in an onPressed, you return the provided fleet of cars instance, car number 1 instance, and you call the method change car color. And then for the child, the one that we don't rebuild, the child of the value listenable builder, which was already declared up here. Now the reason I laid it out this way is so that you would see what the child is before we actually used it. because in reality, you're going to put the child after the builder. And that can tend to make people who are entrenched in the thinking that you always have to declare something before you can use it. That'll make them nuts, because we're actually using it in the builder before we physically read it on the screen. But if you notice something, this and this right here are on the same level. They're indented to the same level. So technically, you can rearrange them any way you want. Okay, they are named parameters of the same thing. But because the linter rules say this has to be last, we're going to end up having it declared below where we use it. Normally, when you're doing this, you will call the type and use the word value, and then the type of the child and the word child, unless you don't have a child, in which case you use an underscore, just to indicate that we're not using that parameter. And that's pretty much it. We close out the value listenable builder here. So what we're going to do now to show the words of what the car is, we're going to do the same thing again. We're going to create a value listenable builder of type string. We're going to be listening to the provided fleet of cars instance, car number 1 instance name right here. Then after that, we create the build context in the builder, or we use it. We have the value of the string, so it's string value, and we're not going to use any child. Why do we have this here if we're not going to use it? Well, because that happens if we don't put something there. So what we're going to do is we're going to put something here. Actually, that would just confuse the hell out of people, so please stick with normal convention and use an underscore. So what we're going to do here is we're going to return a text. The text is going to have a string. The string is just going to be value. When you're reading this code quickly, it's very easy to blow right past that. You have to remember that this is whatever is going to be passed in. This is the value that we're notified about on update right here. So that's what changes and triggers the rebuild. This is all normal text stuff, and then we're done. Now you might notice, you probably did notice, car1 name text has been rebuilt. For every single string in this example, and there are 6 of them, I have put this print statement. And the reason that I put it there is so that you can see that the builder function fires. You can see every single time this builder function fires. And you will see every single time any of the other builder functions fire that have strings. So there's a color one, and here is the one for car number 2 name text. So we have a bunch of these things. And when you look at it actually in production code, here's the way it's going to look. Your value listenable builder listening for type color has a value listenable. Provided fleet of cars instance, car number 2 instance listening for the value notifier of type color, or called color, I'm sorry. That is listening and using the getter color. Our builder function is using the context, has a color, named color, which actually technically what I should do is call that value. Color that we're going to call a value, a widget that we're going to call a child. We're going to return a floating action button. The background color is going to be whatever our value is. Our triggered function returns the provided fleet of cars instance, car number 2 instance, change the color method. Then we're going to use the child. What child? Oh yeah, the one down here that we haven't looked at yet. This can make you nuts. Don't let the fact that it's flipped screw you up. So once again, we've got directions car, black 54, we're done. Value listenable string, listening to the name. Same thing, value, we don't have any child. We're going to return a text. The value is our string. All done. It's that easy. So let's take a look at this actually in action. So here we have 3 white Beamers. Popular car. They're all stopped. Maybe they're broken down. No, we didn't create a Boolean for that. So anyway, what we want to do now is the first thing we want to do is we want to stop this from running because that was left over from another time when I was using this. We need to run this again. Now you'll notice that my console is in dark mode. That's because when I changed my color scheme over, for some reason it doesn't change the console. And as silly as that is, it actually has given me something to talk about while we're waiting for Gradle to rebuild, because I can't go run off and get coffee the way I usually would. Yes, yes, yes. Let's dump all that so that we can see what's going on here. Now, once again, we've got 3 white Beamers. When we trigger this and we change the white Beamer to a yellow Audi, you'll see that car number 1 name text is rebuilt. Nothing else rebuilt. Now car 1 is moving, but nothing else rebuilt. All right. 2 name, 3 moving. 3 name. 3 name again. 3 name again. 2 moving. That's the important point here. Nothing else gets rebuilt. This method stupid proofs unnecessary rebuilds. I like stupid proof. Anything that can keep me from screwing it up, I like it. Because, yeah. I won't call it idiot proof because every single time I idiot proof something, they make a better idiot. Okay, so we're just going to call this stupid proof. And with that, we're done. It's that easy. So if there's any other part of this that you want to go back over again, well, that's why I made it a video. And remember, if you like this video, if you like the Medium publication, if you're benefiting from everything else that Flutter Community does, please consider becoming one of our patrons. Again, at patreon.com/Flutter Community. Thank you, and have a great day.